and this is MOSFET acts as an amplifier. Here if you see, for D MOSFET we are not giving this DC voltage, but for E MOSFET we should give this is minimum DC gate voltage. Why? Because we need a minimum threshold voltage in order to conduct, as there is no channel in E MOSFET, so we need this much of voltage Vg. Okay, then similar to that, here we are applying some see here the gate voltage Vg, minimum gate voltage is obtained from here. Okay, so this is the input of AC voltage applying at this point. If you project this on to the characteristics, you will get the output voltage. So these are the transfer characteristics of the E MOSFET. If you project on this, you will get this voltage. Okay, here we are just doing some jiggling on the forward Vg only, means we are increasing the Vg on forward side and means on positive side, and we are reducing the same Vg voltage on the positive side only. Okay, so remember that. Okay, this is positive and this also should be positive. It should be clamped upwards, so that this is positive and this should also be positive. Okay, so that we are increasing the positive voltage and you are reducing the positive voltage. Okay, increasing positive voltage and reducing the positive voltage, so that it is mapped onto this, so that for a small input signal, voltage signal, we will get a large current signal at the drain current, and this large current signal multiplied this resistance will give us a large voltage V out across the output side. Means V in is amplified at the V out. So this is a MOSFET acts as a amplifier. Hope you understand. And RD is the drain resistance, RS is the source resistance, R1, R2 are potential dividers. Means we have a VD, okay, but we need only VG. Okay, to reduce VD to VG, you have to divide the potential with voltage divider rule. Vg is equal to VDD into R2 by R1 plus R2. Okay, or you can see VDD equal to IDRD plus VDS plus IDRS. So this is one loop and this is another loop. Okay, so VDD is equal to I1 into R1 plus R2. Like this also we can write. Okay, so if we see this loop, VDD equal to IDRD plus VDS plus VD. Just we are just adding these potentials. Okay, so ID into RD plus RS plus VDS. So RD plus RS is VDD minus VDS by ID. Okay, so the sum of these drain and source resistances are this much. Okay, VDD is applied voltage, VDS is voltage across gate and source. We can measure it by just connecting a voltmeter or something, and we can measure this ID voltage also by connecting an ammeter, so that we can get RD and RS values. Okay, so RS is Vs by ID, RD value is, what is this, RD, VDD minus VD. So this voltage is VD and this voltage is VDS. There is a difference between VD and VDS, remember here. So this is VD, voltage across this part is VDS. So what is this one? This current is this voltage minus this voltage by this resistance. VDD minus VD by RD will give us ID. RS is, what's this? This one. So Vs. So this point is VD, means this is Vs. So VD minus Vs is VDS. Understand? So Vs by Rs will give us ID. I hope you understand. Okay. So these are the characteristics, output characteristics. I told you these are transfer characteristics. It is between VGS and ID. This is output characteristics between VD and ID. Output voltage, output current. So this resembles your transistor characteristics. You're not aware of transistor characteristics. So output characteristics are like this. For VGS 15 volt, 10 volt, 5 volt. If you apply 15 volt, output current is this much. 10 volt VGS, output current is this much. 5 volt VGS. So this is a field effect. By increasing or reducing the field voltage, you will get a different ID currents. That's why field effect transistor. Okay. So this is for enhanced type. For depleted type, it is same as that one, but for depleted type we can apply negative gate voltage also for Mosfet as well as along with the positive gate voltage. So you will get the characteristics like this. This is enhancement mode and this is depletion mode. That is the reason why this is called a DE Mosfet. We can achieve both enhancement and depletion. Whereas in this case, we can achieve only enhancement. There is no provision of applying VGS. And this is VTH. This is not 0. VGS is equal to 0. VGS is equal to VTH. That is this voltage. This is the minimum voltage where the drain current is 0. From here it starts. Okay. If you increase value more than this, 5, 10, 15, the drain current keep on increasing like this. See some points about E-MOSFET. Conducts when a suitable gate voltage gate to source of positive voltage is applied, unlike the depletion MOSFET which conducts only gate voltage is 0. Gate voltage 0 ఇచ్చినా కూడా కండక్ట్ అవుతుందండి. ఓకే, ఇక్కడ డిప్లీషన్ మాస్ఫెట్లో గేట్ వోల్టేజ్ 0 ఇచ్చిన కండక్ట్ అవుతుంది. ఎన్హాన్స్మెంట్ మాస్ఫెట్లో మనం గేట్ వోల్టేజ్ 0 ఇస్తే కండక్ట్ కాదు, ఇట్ వోంట్ కండక్ట్. ఓకే, however due to the construction physical enhancement there is a minimum gate to source voltage. Okay, so please go through these points. We have already discussed all this. Go through this once again. Okay, so this is the potential difference that is at this point. How the voltage is divided means VD VGS or VG is equal to VG means VG to 0 voltage between these 2 points. VG is nothing but VGS, this with respect to ground. So VG is equal to from voltage VDD into R2 by R1 plus R2. That's what here mentioned. Okay, the operation what we discussed is clearly given here. Input voltage Vin is capacitive coupled and to the gate terminal. In the absence of DC signal, VGS is equal to 0. Okay, when this is applied, VGS swings. That is, we are applying AC voltage right at the input. That's why VGS swings above and below the 0 voltage, producing a swing in the ID current. Okay, so gain of this amplifier. What is gain? How much voltage is increased from output to input? It is nothing but V out by V in. That is equal to AV. That is equal to GM into RD, where GM is a transconductance. We have already discussed in the earlier slides. Into RD. RD is the drain resistance. And RAC is equal to RD parallel RL. RL is the load resistance, RD is the drain resistance. Okay, this is AC resistance. Total resistance, AC resistance available at the output. RAC is RD parallel RL. See here, this is RD and this is RL. RD parallel will give us AC resistance at the output. Sorry, this is RD. RD parallel will give us AC resistance at the output.